Welcome to another Baka commentary review. In this video will be the topic of the recent x86 ecosystem advisory group and hopefully I can explain why it's happening and hopefully you also understand. So, let me first explain what is x86. This x86 is is mainly right now on the really mainstream on the desktop. You know, like this giant tower PC that you see for like gaming, working you're probably using an x86 desktop, and for laptop, again, quite a majority, like not over 90% of the market is x86 laptop. Like you probably, again, this, you're wondering, how has x86 become like this, where basically is majority of the desktop and laptop market share? Because x86 is a long legacy product, and a lot of time there's long legacy both product in the software and hardware, and as well as there is plenty of documentation on basically teaching people how to use this thing, how to use it, and how to program for it. And as a result, x86 has now this long legacy of long support, long user base since I'm sorry, and majority of people alive right now on Earth has interacted with x86 in some part of their life, even though they may or may not be aware of that, hey, the device that you're using was an x86. However, this legaciness does come with a few downsides. If you're unaware, in the technical world, there's a thing known as technical debt, which means a lot of stuff, a lot of code, a lot of feature hardware that are kind of there for only legacy support and isn't really used anymore, but at the same time, the new stuff kind of relies on the legacy code and feature that is, if you take out the legacy stuff, so the newer x86 feature and code don't work, so like you end up with a situation where it's like, have you ever like a feature where it's like, hey, like certain parts of the software is like, hey, that code is doing nothing on paper, but if we get rid of that code that does absolute nothing, it completely bricks our software and new hardware. So like this is kind of the problem, well, with the x86 and the TLDR of the technical debt. Meaning, as well as you're wondering, what are real life example of x86 legacyness being really a problem? You probably are aware Intel 13th and 14th gen had quite an issue. Because why? They were an x86 design because they had to support a lot of the x86 legacyness. They had to push the 13th and 14th gen CPU beyond what they were comfortable with, which even on the 12th gen was kind of like on the busting, like on the borderline of, cracking. And finally 13th and 14th gens like, yeah, we're cracked and broke, and the technical debt just overwhelmed Intel and be like, yeah, you can't get away with this anymore. As well as, well, on the software side, you probably will be very well aware, Microsoft Windows. For some Windows 10, when you go into Windows and you go and start digging into control panels or some really old stuff, you're wondering, why do they, and you'll find like some really old Windows EXP, Windows Vista, or even Windows 95 features, interface in Windows 10 and 11, that is 21st century 2024 design. You're wondering why? Because Microsoft has found out, be like, hey, if we can't get rid of these features, because if we get rid of them, it will brick Windows. Or hey, we can't rework Windows with feature like that, because if we try to rework it, it again breaks whatever the networking or whatever the IP thing is like. It just fundamentally bricks Windows if they try to hold. And again, how does Microsoft doing this? They're right now they're basically trying to rework the system. They're going to do a crossover thing where at the same time they're going to have they're going to still have the legacy stuff, but they're going to try and hide it away with a new overlapping thing to be like, so like when you go network management, instead of, going to the ancient Windows 98 freaking control panel they just went, we're gonna have it 98 there, but we're gonna slap a in the new probably control panel thing where if we click networking, there's this new networking interface that is basically just a click interacting this new interface that we give you, but in fact you're just a graphical interface to interact with the old like Windows 98 like interface stuff. And yeah, now that hence I've explained what is x86. Now to kind of explain what each of the members in the x86 group gain from this. So you probably are aware the two biggest x86 license holder, Intel and AMD. These guys, they're probably the main fundamentals, the core members of this x86 advisory group. Why? These guys, they hold 99.9% of the x86 IP and licensing. If you want an x86 license, you are going to want to go to Intel and AMD. And as for all others, all they're probably doing is licensing off of them, or they're just operating the software. So, wondering, what does this, has Intel and AMD kind of collaborated? Yes. You're wondering why your AMD CPUs or your Intel CPU is able to run the software that is programmed on the AMD hardware, or the AMD able to run on software that are or games that are programmed on Intel. This is thanks to the private collaboration. It is Intel be like, yeah, here's what our software is, here's what we're doing. Here's AMD telling Intel like, hey, here's how our x86 is functioning. And they're basically going like, hey, we'll have a truth that our stuff will work, your stuff will work. None of us will intentionally go kill each other, or we're gonna intentionally have a made on Intel program will not work on AMD, and AMD would be like, well, we're gonna have software programs work on AMD and we will not work on Intel, basically. Privately, they have been doing that for a very long time. Now, officially, they're doing this in public, and basically this on top of, Intel and AMD probably realizing the technical debt the x86, and they probably want to slowly work together and be like, hey, here's how we can mask old features and modernize it, or here's what the legacy feature we can get rid of, and what we can do with each other, and be like, what we can do to push the x86 software and hardware design, and be like, hey, can you stop using this legacy feature? We want to stop supporting this legacy feature, And basically, yeah. So, what else? So, this is why I think the AMD and Intel is in this x86 advisory group. So, the next company in this question I like to explain is Qualcomm. You're wondering why. The Qualcomm, you've probably seen it. Every retail computer that sells computer, you probably saw Copilot Plus. And you would see some ARM, some Qualcomm Snapdragon Elite X laptop or your phone is using a Qualcomm chip, guess what? These guys, they have the ambition of getting into x86, well, Windows territory or Windows desktop and laptops, and wants to take some of the market share. This also is needed. They're getting into this x86 group is because they want to know what is the x86 standard so that they can design the ARM core to around this x86 IP to emulate x86 apps. If you probably saw this with a lot of the Qualcomm Snapdragon Elite X laptop reviews. They came with a lot of issues where the laptop for the applications and for the GANT software that had native ARM variant, it was working flawlessly with the new Qualcomm Elite X's. Meanwhile, the x86 stuff, it had came with a lot of performance penalty and quite a lot of time. It just simply did not work. Simply, Qualcomm, by them going into this x86 advisory group, they are now able to go, hey, can we have a standard that the x86 we all agree on so that the ARM can start developing, catching up the emulation of x86, which x86 had plenty of heads up on, emulating ARM devices, okay? This is why, again, I think my analysis on why ARM is in this x86 group system. Now for the last partner slash person company that have their interest in this x86 group and that hasn't had their logos on it. You probably haven't heard about it because they're very, very small and niche, and that is RISC-V. You're wondering, how does RISC-V come into this picture of this group? They are part of, in my opinion, part of Dell, Hewlett Packard Enterprise, HP, Lenovo. These guys, guess what? These guys, they all share. They are just product vendors. They don't care what they sell. All they care about is we don't care that this is a ARM, a x86, or a RISC-V product. All they ultimately care is selling us viewers and a lot of everybody on Earth a product, and they are there to make money. RISC-V is an upcoming like design product software for like CPU cores and GPU for technology that is open source, and it's very, very cheap to get into, and as well as it is basically brand control. The brand like Dell, HP, Lenovo, they can control the whole ecosystem. So imagining like a whole Dell ecosystem, a HP ecosystem, which only, and Lenovo ecosystem, which only works with their respective brand. That's what RISC-V is enabling these vendors do. Have a closed ecosystem, or maybe an open, some begrudgingly open system where it will work across the brands, but like it wouldn't be the best. But you bet when these vendors saw this RISC-V being cheap and you can do these semi-closed system, you bet they can do that by like, let's just take for example, a Dell or Lenovo launches HP and Lenovo launches a new, a laptop. They have this new, with the new every generation they're able to pluck something out of the RISC-V IP and be like, new feature. Here's our new generation. We have this new feature. Please go buy our new product. Or, hey, we support an update for it, but we will gimp your, experience because you don't have the latest generation of our product. And we kind of slowly nudge you towards, and they can like vend this RISC-V and basically these LHV, I see them as like kind of a conglomerate where it's like to push to be able to fully control the consumers when they buy, what they buy, and hence this is why I think Risk 5 has basically a say in this x86 advisory group. But yeah, here brings the end to another of my Baka commentary video. And if you'd like these content, do the typical like and subscribe and share to get more people aware of this channel, and I'll see you guys in the next video.